A and B. What is an example for a unilateral element? Both diode and switch will be falls under unilateral element. Why diode and switch both will be falls under unilateral element?
Because both work in
Because
one direction.
yes, diode will allow
Sir, yeah.
only forward bias. Right. And
Yes,
the
the
second
current is
question,
similar.
all linear elements are
Obeys
Which
Obey
obeys
Ohm's law.
Ohm's
Obey
law.
Ohm's law.
Obey Ohm
ohms.
law.
All right. Your option number A. And battery is an example for which category of element?
Active.
act,
Active.
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 Which can
Active.
delivers energy. So the final one, the elements which receives or consumes energy. Such elements are falls under
Passive.
which category? Passive. Good.
Passive.
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 Very good. Very good. So I hope everyone joined. Around 31 students have joined. Anyhow, we will start the today's session. Today we are moving on to our parameters of resistance, inductance, and capacitor. So before we are moving on to these resistor, inductor, capacitor, these are the keywords for today's topic. You have to remember this. At the end of the session, you need to have full clarity on these 5: resistor, inductor, capacitor, and a series combination and parallel combination of these 3 parameters. So before I am moving on to the resistor, inductor, capacitor in detail of their series and parallel combination, I hope these everything should be you learned in earlier, but just I'm going to brush up all these things. So can anyone give me the Ohm's law?
Sir, Hassan is waiting in the waiting room. It seems like admitting.
Waiting room, yes, I allowed. So can
Voltage is
anyone,
directly proportional to the
voltage is directly proportional to,
Directly proportional to current.
Resistance.
okay,
Current.
resistor.
Then resistance.
here I will write.
At constant temperature.
Good, very good. At constant temperature. That is the condition need to be satisfied. So at constant temperature in an electrical circuit, the current, I will draw the circuit also. Your voltage source and your resistance, the amount of current which is passing through it. Second, 2 more people are waiting. Okay, right. So here we are having one electrical circuit. So for this, I am giving the statement of Ohm's law. So at constant temperature, the condition need to be followed. In an electrical circuit, the current which is passing through a conductor from one terminal to another terminal of that conductor
Another term.
directly proportional to the voltage present across the terminals, or simply the potential difference present across the 2 terminal points. So that is directly proportional to I. So in order to remove the proportionality constant, we have the rule in our mathematics, we must follow the constant. So the proportionality constant here I am taken as capital R. So where R is your proportionality constant, and that should be named as, what is R?
Resistor. Ohms.
Resistance.
Resistance.
Right.
Resistor.
So what are the units for resistance?
Ohms.
Ohms.
Because who given this statement as a honor, we are given the units of this resistance as ohm, the name of the scientist. Okay, done. And what are the limitations of this Ohm's law? Now we got the information what is Ohm's law and at which condition it needs to be getting followed, done, and what is the formula, right? And what are the limitations of this law? Everything should be having some limitations. Every statement which is proposed by any scientist have some limitation. So is there any limitations for Ohm's law? Simple. It is applicable only for metallic conductors. It is applicable only for metallic conductors. Metallic conductors in the sense your copper, silver, like this. Like copper, silver, your nichrome, right? And what is the another limitation? Here it should be followed the condition of constant temperature. That means it is not applicable. One more in waiting. So the second limitation was it is not applicable for all electrical circuits, such
Insulators,
as simple your semiconductors.
semiconductors, insulators.
Why semiconductors? Because these diodes, what are the semiconductors? You know, diodes, transistors, and one more thing, it is also not applicable for thermistors also. What is thermistor? Simply, which you can senses the temperature, right? Which can measures the temperatures in industries, where the industries have the heavy and nothing but very very high temperatures. So in order to measure those high temperatures, they are using device called thermistors. So when the temperature detection device, in the sense, it should not maintain a constant temperature, right? There is a fluctuations in the temperature. So therefore, that thermistor did not follow the Ohm's law. Okay, I think my voice is audible to everyone. Having any disturbances?
No, sir.
No, sir.
Sir, audible.
Okay, okay, fine. Thank you, ma'am. All right. So about this Ohm's law, right? At constant temperature, the current which is passing in an electrical circuit through the conductor from one terminal to another terminal of the conductor is directly proportional to the potential difference or the voltage which is present across the two terminal points. Where by removing the proportionality constant, we are having the resistance parameter. The units for resistance are ohms, right? So shall you guys give me the Kirchhoff laws? Kirchhoff laws. I hope these are already you studied in your school standard or maybe in your intermediate. Ohm's law, Kirchhoff law, resistor, inductor, capacitor. But I need to just define them once again.
Sum of the currents passing through the junction is equals to
Hmm. Kirchhoff's law.
sum of the currents away from the junction.
Okay, that will be falls under which law? KCL. That is the first one. We are having the two
Kirchhoff law of
Kirchhoff
current,
laws, right? Kirchhoff
Kirchhoff's law.
current law and Kirchhoff voltage law. So now we are
voltage law.
given the statement for Kirchhoff current law, that is KCL. So this KCL will be also termed as junction rule. Remember, in some of the textbooks, they may mention as Kirchhoff's junction rule, and in some authors, they mention as Kirchhoff's point rule. All are same. No need to confuse. In your examination, also, if they are asking, give the statements of Kirchhoff point rules, then no need to confuse. That is your Kirchhoff current law. Okay, similarly, Kirchhoff junction rule. So simply we can give the statement in two ways. The Kirchhoff current law, we can give the statement in two ways. The first one is, here I will draw one circuit which is very, very, very familiar with all of you because you draw so many times.
Current flowing from one junction should be equal to the
Right. I hope everyone have
junction
this
flowing out of it.
circuit earlier.
Yes.
Yes,
Good.
sir. I3, I1, I1, I2, I3, I4, I5.
Yes. So this is your junction point. So can anyone give me the equation now? The currents which are entering at this junction point.
I1 plus I3, I1 plus
Sum
I3
of
equal to I2 plus
currents
I4 plus I5.
I1 plus I3 equal to I2 plus
I2
I4
plus
plus.
I4
I4
plus
plus
I.
I5.
Plus I5.
So in first category, we can define or we can give the statement as the sum of currents entering at a node entering at node or junction is equal to
Must be equal to the
sum of currents which are leaving
sum
from
of current flowing out,
right flowing out or leaving from the
leaving out
junction
of it.
point or node point. Right. So shall I write all the parameters in left hand side? I1 plus I3 minus I2
Minus
minus I4 I5 is equal to 0.
0.
So your another statement will be like the algebraic sum of currents meeting at a node is 0. Right? That is this one. So we can define in both ways the statement of Kirchhoff current law. Okay. And what about Kirchhoff voltage law? The second one. Kirchhoff voltage law. Can anyone tell me what is the statement of
Sum of voltage,
sum of
is
voltage
equal
at
across
junction
the
is equal to na?
to zero.
Once again,
Sum of voltage across the circuit is equal to zero.
good, good, good. A little bit correct. Almost you are missing that the algebraic sum of voltages.
Voltages around any closed loop is 0.
Good. Around a circuit must be 0 or in a closed loop is equal to 0. So here I will draw the circuit. So before I am going to draw the circuit, I will give the another names of your Kirchhoff voltage law. That is, we can also call it as a loop rule because here we are considering the loop, closed loop. So we can also call it as a Kirchhoff's loop rule. Here I will draw the circuit. Your first resistance, second and third all are connected in series combination. So here just I am giving the polarities of the voltage presented across each resistor V1, V2, V3, right? So all of you carefully identify this is your, let us take as Vs as a supply or source voltage for this entire circuit. V1 is the voltage drop which is presented at R1. V2 is voltage drop which is presented across R2. V3 is voltage drop which is presented across R3. Okay, now three resistances which are connected in series. Now here you need to focus on how I am writing the circuit equation. See, what is the Kirchhoff voltage law? Simply the algebraic sum of potential differences around a circuit must be 0, right? Right, simply nothing but while applying KVL to a closed path, we need to assign the polarities we already given. Now check around the closed loop, the algebraic sum of voltages are 0, what I mentioned. So see, this is your closed loop, circuit is closed. So where the arrow mark, this arrow mark indicating the flow of current in this closed circuit. So this arrow where it is entering for this first source voltage, which polarity?
R1, V1.
No, no, no. This direction will be entering to the first polarity. So which
Negative.
polarity? Negative. So minus what is the value of
Clockwise.
that voltage? Vs. And then it is move on and entering at R1. What is the voltage drop? Polarity
Plus,
is
plus
plus. What is the value of that voltage?
V1
And next it will be going and entering at second resistance with voltage
plus
drop
V2
V2, right, plus V2, and for third
plus V3.
plus V3 equal to 0. Now The equation satisfied that the algebraic sum of voltages around a closed circuit is equal to 0. That is your statement of your KVL. Now Vs is equals to, shall I write like this? V1 plus V2 plus V2. Alright. Understand your Kirchhoff laws, KVL and KCL. Very,
Yes,
very
sir.
important. Na? From last 2 years, they asked 2 times for 5 marks. And the last month, what the JNTUH exams are conducted for your seniors, they asked same, explain Kirchhoff laws in detail with an example. With an example in the sense, you need to draw this circuit, you need to draw this circuit, you need to explain it. Okay. With example in the sense, or else you can draw the circuit. In additional, you can take some values like 10, some 5 volt, some 3 volt, some 2 volt. So therefore 10 equal to 5 plus 3 plus 2. Okay, like that. You have to take an example. Done for all of you. Kirchhoff voltage law and Kirchhoff current law, very, very important.
Yes, sir.
Examination point of view. Right. So now shall we move on to our regular topic of resistors and inductors and capacitors.
Okay, sir.
Right. See now. So what does it mean by resistor? Simply, it is a passive element. Already we know that in last class, right? It is a passive element which can consume, it does not store, but it can consume energy, right? So it is a two-terminal electrical component where it can implements the resistance as a circuit element. See here, you need to remember that resistor is an element. Resistance is its property. That means which can oppose the flow of current. So already Ohm's law, we got it, Ohm's law. So before we are moving on to the derivation of this, I will share the whiteboard once again. It should be indicated by capital R, right? This is your symbol. If two resistors which are connected in parallel. See, before I am moving on to the electrical resistance in detail, will anyone tell me the formula to calculate the resistance of a wire or any conductor in physics? We have another formula with the fundamental.
Rho into L by A.
Good, good.
Rho L into L by A.
Very good. R is equal to rho L by A. Nothing but simply the resistance of the conductor is directly proportional to the length of the conductor. Nothing but simply from the fundamental, what I am writing here. Sorry, not rho.
Ly.
Right. The resistance of the conductor is directly proportional to the length of the conductor, and which is inversely proportional to area of cross section.
Area.
Cross section. Right. I think one more candidate in waiting room. Sai Bharat. Okay. Now, so by removing this proportionality constant, your R is equal to, sorry, by removing
Rho L by
proportionality,
A.
we kept the constant, that is rho. So what is meant by rho? Resistivity.
Resistor conductivity.
Good. Resistivity of
Res-
conductor. So what are the units for rho? See, what is the units for R?
Ohms.
Shall we write rho equal to R A by L?
Meter per second.
Your resistance ohms. What are the units for area of cross section?
Meter
Meter
per.
square, and units for length, meter. So your units for resistivity is ohm meter. Okay, done. Good. So when two resistances which are connected in series combination, let us take. This is your voltage source, your R1 and R2, voltage drop V1, V2, right. Now tell me what is the equivalent resistance here for this circuit or total resistance?
V1 plus V2.
R1 plus R2.
R1 plus R2. I think everyone well known, right? When two or three resistors
Yes,
which
sir.
are connected in series, it should be the summation of all the components of given resistances. So now how this R1, R2 will coming? How you
We
told this? Just, just you need to apply your KVL. So shall this is an example for KVL looking like?
Yes,
yes.
sir.
So you need to apply that. So where the arrow mark is entering at negative of supply voltage V plus V1 plus
One plus
V2
V2
equal to 0.
equals to 0.
What is V?
We
This is your current, right?
V2.
Total current I,
I
the amount of current. So what is V? Total current multiplied with total resistance. So minus I into your total resistance is R equivalent
I R2
plus your V1. V1 is I into R1. Your Ohm's law. You need to apply your Ohm's law. I R1.
R1
This is
plus
circuit
I R2
I R2. Now I is
equals to
getting
0.
common. So by taking I as common,
Minus
so by taking I as a common factor, shall we, I'm directly writing R equivalent equal to R1
R1 plus
plus
R2.
R2, right? Derived from your application of Ohm's law and KVL.
Yes, sir.
Right.
Yes, sir.
If n number of resistors are connected, if n number of resistors are connected in series, then what is the equivalent for that? R equivalent equal to R1 plus R2 plus R3
R2 plus R3
So on up to
plus up
R3.
to
on up to Rn.
R. If
Rn.
n, if n identical resistors, these kind you can ask, they will ask in the competitive examinations. If n
NR,
identical
sir.
resistors, right, very good, are connected, then R equivalent equal to NR is the answer. These three are important. You need to note it down and make it as a box. And we will go for the next combination is parallel.
Parallel series.
Anyone, if anyone switch on video, you can turn off. No? Right. So during parallel combination, I will take another example. So two resistors here I am taking in parallel combination across the voltage source R1, R2, current passing through it I. See here there is a junction point now. So the amount of current passing through this circuit, now it should be having two paths.
R1 and
Correct? So shall I take this as I1, I2?
sir.
I1 I2.
Right. So I hope you guys know what is the equivalent resistance for two resistors which are connected in parallel. 1 by R
I
equivalent
1
equal
by R equal to
1
1 by
by
R1 plus
1 by
R2.
R1 plus 1 by R2.
So how it came, we will see that. So at junction point is presented here.
Equals.
So that shall we apply the junction rule? Nothing but your KCL. Here I am applied KVL. Here we are going to apply for KCL because we are having one junction point. So sum of entering currents. Here entering current is only one, that is total current,
One.
capital I.
I.
And sum of leaving currents, I1 plus.
I1.
I1 plus I2.
So your I is total current. That means from Ohm's law again, you need to apply Ohm's law. I is total voltage by
V
total
by R.
resistance.
V by R.
And
Yes.
I1, again voltage is constant
V
in
by
parallel.
R1.
So V by, for this first resistance R1. For
100
second resistance
plus
current value.
resistance R2.
So by taking common and cancelling both sides, 1 by R equivalent to
1 by R1 plus 1 by R.
go. So for the same, if n resistors are connected, same like as your series for parallel, if n resistors which are connected in parallel,
N by R, sir.
then it should be
Need to R.
1 by R equivalent is equals to 1 by R1 plus 1 by R2 C1 plus 1
So
by
on up to 1 by RN.
R by N. R by N, sir.
R
Correct.
by.
That is for n identical resistors. If identical resistors in the sense there is no R1, R2, there is only R like that. Those are called identical resistors. For that it should be R by N.
And
Okay, note it down. So once it should be finished, we will go for inductor. Done for everyone.
The characteristics would become minus y. Can anybody give a reason? And
If anyone still noting, you can inform me, or else I can shift to the next topic.
Done, sir.
Done. Okay, fine. Thank you. So here, by the conclusion of resistor, I want to give the one more point which can useful for you in the laboratory itself. See, this kind of symbol is called a resistor, and this resistance we can call it as a fixed resistor. Okay, the fixed resistor in the sense, if you want to keep one resistor like something, or let us take an example of 30 ohms. So you want to keep it as a 30 ohms in your experiment, you have to go to shop and you need to take the 30 ohm resistor and you need to install it, right? So that 30 ohm resistor you cannot change it to 40, you cannot change it to 20, because that value should be getting fixed to 30 ohms during its manufacturing. Okay, try to understand. Now there is another component in the category of the resistor that will be give the symbol like this. Representation will be like this. Representation of a letter will be R itself only. So this arrow mark indicating that you can vary it. That is called variable resistor. These kinds are called variable resistors. Okay, variable resistors where you can vary the value of given resistance. Let us take an example of 30 ohms again. But here in this 30 ohms, if it is a variable category of resistor, you can make it as a 20, you can make it as a 10, you can make it as a 2 ohms, you can make it as a 0 ohms also, but you cannot make it as more than 30. Okay, you can make in between 0 to 30. So such kind of variation we have the possibility in variable resistors. But whereas in fixed resistors, that will be getting fixed, but there is no alteration present. Okay, that facility should be available only for the variable resistors. These kind of variable resistors, we are also treated as a rheostat. We can use them in the laboratory. Okay, whereas in fixed resistors, we can also use in laboratory to do the experiments like Ohm's law, Kirchhoff voltage law, current law, like that, because the values of resistance are specified. But if you want to do some experiments on the machines, nothing but your motors, generators, where you need to vary the resistance according to the presence of current. So amount of current drawing, if it should be very high, then immediately you need to reduce the resistance. During the time we are not going for the direct live. So we can just use the variable resistors where we can decrease the resistance from 100 ohm to 70 ohm, like that. So where we can utilize these variable resistors. Okay, understand the difference between the fixed and variable resistors?
Yes, sir.
All right. So I will get back to our PPT. Right. And these are the symbols. Resistor, that is a fixed resistor symbol, and variable resistor symbol. And as a summary, the series combination of n resistors and in parallel combination and its equivalent resistance formula. And when we move on to the inductor, the next one is inductor. So inductor, in the sense, I hope everyone know, this is a symbol of inductor. That is just a twisting or turning of your coils, right? Where the inductance, I will go for as physics first. Later I will move on to electrical. I will go to whiteboard. So our next parameter is inductor, which is indicated as right, the symbol, amount of current passing through it, and the voltage which is presented across the inductor. So before these voltages and the currents, I will move on to the your fundamental of physics. Can anyone, any idea on the formula of physics, like your R equal to rho L by A? So just note it down, everyone.
V equal to Li.
No, no, no. Again, you are
V
involving
equal
the
to Li.
electrical parameters, where V is electrical parameter, V and I. So anyhow, you have to note it down. It is the property of a circuit element. All of you note it down. It is the property of a circuit element by which, once again I am repeating, it is the property of a circuit element by which it opposes the change in flux, by which it opposes change in flux, by which it opposes the change in flux or current. Current is an electrical parameter where flux is what, like physics, nothing but magnetic flux. Full stop. The inductance of a coil we can also define as, the inductance of a coil is also defined as the ratio of flux linkages, ratio of flux linkages to the current flowing through coil. It is the ratio of flux linkages, nothing but N phi. N phi is the flux linkage. Flux linkage in the sense how much or how much amount of the flux which is presented in the number of turns, where N is the number of turns, remember, or else you can note it down. The number of turns of coil, nothing but these 1, 2, 3, 4. How many turns we are having in the
Sir,
coil?
1 second, sir.
Right, right. I will give the once again the definition. It is a property of a circuit element by which it opposes the change in flux or it can also defined as the ratio of flux linkage, the ratio of flux linkage to the current passing through the coil. This is the current passing through the coil. Flux linkage to the current passing through
Passing.
the coil, right? So where flux linkage in the sense how much amount of the flux which is linking with the number of turns, where phi is nothing but your flux units are Webers. For the flux, the units are Webers. For number of turns, there is no units because that is a constant value. For current, the units are amperes. So as a whole, the inductance units are Henry. This is as a part of your physics. L equals to n phi by L. That should be getting interlinked with the electrical also, where flux and current and number of turns. But we know from Ohm's law what is the relation we are having, the voltage V and I relationship for a pure inductor, V equal to L into di by dt. We know that. Then from this, can you give me the formula for current? I equals to V by L,
dq by dt,
right?
v by
1
r.
by L into V dt, right? Just I'm giving di by dt equal to V by L, where L is a constant term. So 1 by L integral V dt. The voltage and current relationships. See, I forgot to give the power formula for resistor in earlier. Once again, I will get back. I think it's showing some error.
What is going to happen? More current will get flow when you are applying the load on this. Okay? Some load on this. More current.
Okay, okay. Anyhow, I will tell the power here. You can note down in the resistance page. At the end of the resistor parameter, we have to note it down as the power absorbed. The power absorbed or dissipated in a resistor. As a side heading, the power absorbed or dissipated in a resistor. So we know from Ohm's law V equal to I into R and R equal to V by I. What is the formula for power? V into I. So will you substitute in the place of V as I into R from Ohm's law? Now what is the formula of power in terms of resistance?
I square R.
I
Good.
square r r.
R. URR in some textbooks they will also mention like P equal to V into I, and in the place of I they will substitute Ohm's law, that is V by R. Now the formula for power in terms of resistance, V square by R. Your units are watts for both. Okay, you have to note it down where I forgot for resistance term. Okay, we have to note it down at the end of the last topic, that is resistor. Now get back to your inductor. For inductor, the formula for power P equals to power in an inductor is given by P into I. By substituting voltage, current you have to keep it same, Li di by dt. Okay, done. So before that, we will move on to the series combination. Okay, I will wait one more moment before the series combination. I think everyone have the clarity on inductor or need to explain once again. All of you got the inductance? Having any doubt, shall I revise or shall I move on to next? I need response. Very important inductor parameter. That's why I'm repeating. Is it going to revise or shall I move on to next? That is series and parallel combinations.
Revise, sir. Revise.
Revise.
Okay, good, fine.
Yes, sir.
Okay, fine. I will revise. Okay, I got chat box. Okay, fine. So revision in the sense you need more clarity. That I understand. That's why I asked. Okay. To get more clarity, I will give one real-time example. See, the symbol will be you guys able to visualize the whiteboard, everyone?
Yes, sir.
Okay, fine. Kindly focus for
Yes, sir.
2 minutes. Focus 2 more minutes. You will better understand the parameter of inductor. 2 minutes. So where here I'm applied some voltage across this inductor. So what is the purpose of voltage? Which gives the force to move the electrons towards the direction of the force applied. So that means the electrons are starts to flow, right? With the force whatever you applied and starts to flow through the path of the inductor and moving on to the second terminal. Am I correct? So here I will give you one example. There is a two directions. Let us take this is as your home and this is our campus. HITAM. Here you are having there is a two directions to reach our campus. Okay. Here I am having one shop and here I am having another shop in the journey. So now you are presented here, right? The students are presented here. So this is the direction one, this is the direction two. So which direction you guys will select? One or two?
Direction 2 with shops.
Direction one or two?
2.
I need response from all of you.
Uh,
Hmm. I need response from all of you. Not one or two students.
One, sir.
Which direction it should be? Obviously, the majority will choose the direction of one. Why? Because it should be having the direct connection. It is having the direct connection, nothing but direct highway road. So there is no disturbances. So the advantage was that it will saves the time and it will saves the fuel of your bike.
Distance.
So that's why majority will choose path one. If you guys are selecting this path, so the first path will be like this. That is a conductor where current is passing through it if you applied some voltage. Okay. Now the second path. So the second path in the sense where the number of electrons. See, you guys yourself treat as an electron now. Okay. So you guys treat as an electron. Now, for example, 10 electrons, nothing but 10 students are started from their home towards the second path. Now they have to reach the HITAM by some delay compared to the first path. But while they are coming, there is a one shop is there, right? So maybe two electrons, nothing but two students may be dropped here and remaining 8 students are started their journey and towards the campus and here one more shop is there. So I think two more students will be dropped here, let us assume. So what is the total number of students reaching at campus now?
6.
6
So 6 electrons, right? So 6 students. So these two electrons are getting stopped here and these 6 electrons are reached. So like this, see here in this direction, while electrons are starts moving on, see there is like a small hole you can assume. In this way, they can store some electrons. In this space, it will store some electrons. And the remaining electrons will start to flow and move on. But it will take some time lag to receive the another side. That means from one point to another point, it will take some time lag for inductor because it is selecting the path number 2, right? Now you are having some clarity how the current is going to pass. What does it mean by exactly? At initial condition, it won't allow the amount of current immediately. It will take some time to allow the current to pass through it. Here I will give another example. Everyone having tube lights in our home,
Yes, sir.
right? So tube light when you, and there is another lights are also there, LED lamp, for example. So if you switch on your tube light and LED light, which will glow first?
LED.
LED light.
Leader.
LED, right? Your tube light will glow later. The why this time lag should be going to happen? Both are lights only, right? Due to their manufacturing, it should be having some time lag, the tube lag. That means it will be having some choke in it. The choke in the sense nothing but your inductor, right? So if you are observing any fluctuations or any voltage dip, nothing but any voltage dim is having in your home, first appliance it should be going to affect is your tube light will be turned off and your LED lamps will be glow a less intensity, right? Here less intensity, here almost zero, because the tube light that should be containing the choke, that is an inductor which does not allow the current, which does not allow sudden changes of current. Okay, so during first time it is in switch off condition. The tube light is switch off condition. That means 0 electrons are presented. If you switch on, that means you are giving some 10 amperes. Let us think. So at a time 10 amperes it won't allow. It will take some time gap of 1 to 5 or 10 seconds based on the manufacturing company. So by taking that time delay, it will start to allow to pass through it. That is the time lag it is having. Okay, that means the property of the inductor is it opposes the change in flux or current immediately, the sudden changes, right? There is a 10 amperes
Yes,
current
sir.
is passing. If there is any voltage dim is happens, the force will be reduced and 10 amperes will be reduced to some 8 amperes now. So these change, this change of flux or change of current, it won't allow. Therefore, it will be switch off during the voltage fluctuations. Right now, I hope the concept is very much clear to everyone.
Yes, sir.
Yes, sir.
Good, good. So this is a very, very important point now for your competitive examinations. Inductor does not allow sudden changes of current. Remember it. Now I will move on to the series and parallel combination. One second. All right. So the inductors which are connected in series combination. Time up. Okay, okay, right. Good. So Shiva Kumar. Okay,
Sir.
right. Represented. Okay, done. Sukant, 42.
Sir, you called my main name, sir.
Not Shivama, 42, number 42, Sukant.
Okay, okay.
Yeah. Mm, there is still 2 more minutes. If you focus just to 2 minutes, we will wind up the inductance term at least. When two inductors
Okay,
which are
sir.
connected in series, just like as your resistance parameter. I will quickly complete. So your voltage, this is your current passing through the circuit, the value of voltages across each element. So quickly, what is KVL? Apply KVL to the circuit.
Minus V is equal
Right,
to V
minus V plus V1 plus V2 equal to
plus
0, right? So where V is nothing but total voltage, so therefore L into LdA by dt, right? The formula, the
yes, sir.
voltage across inductor, nothing but LdA by dt. So that is a total voltage. Therefore, I mentioned as equivalent inductance, nothing but total inductance of the circuit. L dI by dt, the current passing through it is I, that is dI by dt plus V1 for L1. So therefore, L1 dI by dt plus V2 means L2 dI by dt equal to 0. So dI by dt getting common and cancel both sides, and shall we write? Done.
Yes.
If n
Yes, sir.
If n number of inductors which are connected, then it should be L equivalent equal to L1 plus L2 plus so on up to Ln. If n identical, same like as your resistance,
NL.
right?
Right.
So similarly, if two inductors which are connected in parallel combination. Yeah, yes, ma'am, yes. See here, same as your resistors
One
which
by
are
L is
connected in series. Here I am applied the KVL for the series combination of closed circuit, and as per KVL minus V, where the current is entering at the negative polarity of the source voltage, plus your first voltage drop across L1 V1 plus your second voltage drop V2 across L2, that is V2 equal to 0. Just I need to substitute it the value of voltage across inductor, that is LdA by dt. You know the voltage present across. V equal to LdA by dt, the basic formula. What I applied here, where LdA by dt, here V is a total voltage, so therefore total inductance and a total current, that is L equivalent, plus L1 for first inductor V1, that is L1 dI by dt, plus second voltage drop across L2 dI by dt, this is L2. dI by dt is cancelling by taking common. We have to write the third step by taking common of dI by dt and cancel, and the final conclusion should be L equivalent equal to L1 plus L2. Done for series combination.
yes.
Right, for parallel, there is a junction
One by
point, so current is going to divide. So
I2.
apply KCL, sum of entering current I is equals to I1 plus
I1
I2. Now you
I2.
have to do one thing, rather than either you can substitute the current formula directly, that is I equal to, what is the formula? 1 by L integral V dt. Either you can apply this, or simply you can take the differentiation on both sides with respect to t. That is di1 by dt plus di2 by dt. Just here I am applied differentiation with respect to t. Di by dt equal to di1 by dt plus di2 by dt. So di by dt. So from this formula, shall I write like V by L? V by L. That is total. That is V by L1 plus V by for this L2, because this is I2. I2 is the current passing through L2. So by taking V as a common factor and cancelling on both sides, 1 by L1 plus 1 by
1 by
L2.
L1 plus 1.
So similarly, if it is a N, up to 1 by
1
L1 plus 1 by L2 plus so on up to Ln.
1 Ln.
If it is N identical,
L by N.
right. So L equivalent equal to L by N. Very good. So all of you note it down. In the next
Yes.
session, we will complete the capacitor part.
Okay.
Yeah.
Okay, sir.
Someone, Sukant, need to be added in WhatsApp group. Okay. I shared the WhatsApp group link. Okay. Right, if all of you
Sir,
complete,
attendance.
yes, yes, if anyone can take the screenshot and keep post in our group.
Sudhir has already taken, sir.
I
Taken?
have taken, sir. I already submitted.
Okay, now I will check once again.
Check, sir.
Yes, Sudhir shared, right?
Yes, sir. Completed.
Right, thank you, thank you. So all of you noted, those
Thank you,
who
sir.
are
Can we do?
noted can leave. If anyone
Okay,
wants
sir.
time to note it down, you can
Okay,
also.
sir.
Okay.
Yeah, thank you, thank you.
Thank
all.
you.
Yes, I will share that presentation to your group now. Yesterday's presentation I will share today. Okay, no problem.
Sir, please share the PDFs also, sir,
Sure,
from
sure.
Monday's class.
Yes, sir.
Already I shared. Yesterday I shared. Only yesterday's
Where, sir?
PDF need to
In the
be.
ERP?
No, ma, in your BW group I shared.
Yes, you did.
Yeah.
Sir, please add me in BW group, sir.
Will you? Are you there in your official group in cybersecurity?
Yes, sir. Yes, sir. Yes.
There I shared the link of WhatsApp group. I will share once again, Sukant, the link of BW.
Oh, okay, sir. Thank you.
Or else, as I got your number also from Karthik, I will add directly to you. Okay.
Okay, sir. Thank you.
Okay, now shall I wind up today's session or still anyone writing? Right. So take the screenshot and then you have to note it down because I hope you are having the next class. So I am ending today's meeting. Thank you all.